Hello everyone, myself Snehal Shinde, lecturer in Pravin Patil College of Diploma Engineering and Technology from Electrical Department. Subject is Utilization of Electrical Energy. Subject code 22626. Unit 2 Electric Heating and Welding Systems. So in this video, we will study methods of temperature control of the heating element. So the temperature control of the heating resistance furnace is divided into three. First is the variation of number of heating elements. Second is the variation in circuit configuration. Third is the changes of applied voltage. In the changes of applied voltage, there are four classification. First is the transformer with tappings. Second is buck boost transformer. Third is auto transformer, and fourth is the series reactor. So we will see one by one. In the first, variation of number of heating elements single circuit. So if S1, S2 and S3 are on, ABC heating elements gets connected in parallel, where ABC is the heating element and S1, S2, S3 are the switches. The effective resistance is less and current is more. Therefore, heat is more. If S1, S2 are on and S3 is off, only A and B heating elements are connected and heat is less. If only S1 is on and S2, S3 is off, only heating element A is connected and heat will be lesser than the previous case. Second is the variation of number of heating elements double circuit. In this, two separate parallel paths are provided for heating elements and S2 is off. When S1 is on and S2 is off, heating element A, C, E gets connected in the circuit. When S2 is on and S1 is off, heating elements B, D, F gets connected in the circuit. If S1, S2 both are on, the heating elements gets connected in the circuit. The equivalent resistance and total current in each case will be different and heat produced will be different. Variation in circuit configuration, single phase furnace. In this, A, B, C, D heating elements can be connected in different series parallel combination as shown in the figure. In first case, all are in parallel. In second case, a parallel series combination is done. In each case, equivalent resistance and total current will be different and heat obtained will be different. Variation in circuit configuration, three-phase furnace. In this, the three-phase heating element can be switched In star or delta connection, in delta connection, power is 3 times star connection, hence heat developed will be more. In the fifth type, changing applied voltage using tapped transformer. The tappings are provided on the primary side of the step-down transformer. By changing tappings, the effective secondary voltage changes. The resistance heating element connected to secondary side thus receives different voltage. The current through heating element changes and thus heating is controlled. In the next type, changing applied voltage using buck boost transformer. A buck boost transformer has single primary and two secondaries. The two secondaries can be connected in different configuration as shown in the figure A, B and C. In boost mode, two secondaries are connected in series addition polarity. Hence the voltage E2 and E3 are added up and effective voltage is more. Hence current fed to the heating element of furnace is more and heat developed is more. In buck mode, two secondaries are connected in series opposition polarity. Hence the voltage E2 and E3 are subtracted and effective voltage is less. Hence current fed to the heating element of furnace is less and heat developed is less. In this mode, only one secondary is connected. Hence, voltage received by furnace is less than the first case. Changing applied voltage using auto transformer. Auto transformer provides variable voltage to the heating element of furnace. Temperature control is smooth. It is suitable for small capacity furnace. Changing applied voltage using series reactor. A series reactor is connected to the furnace or heating element by means of switch S. When S is on position 1, furnace receives rated voltage. When S is put on to series reactor comes in circuit, some voltage drop takes place across reactor and remaining voltage is applied to furnace. Thus, furnace receives less voltage and temperature is less. The capacitor C is provided for power factor improvement. Here is the comparison between variation of number of heating element, variation in the circuit configuration, change in the applied voltage. Principle is this: changing number of heating elements in the variation number of heating element, and the principle for variation in circuit configuration is changing the connection of heating elements with respect to the each other. Then changing circuit information, it is used in the change in applied voltage. Now process of temperature control is, it is less complex, then complex and less complex. Then the switching process is complex, less complex and simple. Then equipment required is switches and here switches and transformer are used in the change in applied voltage. Temperature control is in steps and in change in applied voltage it is auto transformer, smooth and wide range, buck boost transformer, 2 or 3 levels, series reactor, 2 levels only. So the cost is less and more. The methods used are on-off, series parallel, star delta, connection, auto transformer, buck boost transformer, series reactor. So now next is causes of failure of heating element. In this, formation of the hotspot on heating element is the point which is at higher temperature than remaining heating element portion. So there is possibility of breaking of heating element at hotspot. Second is the due to oxidization. At high temperature, material gets oxidized which may cause failure of the heating element. Third is the due to corrosion. If heating element is directly exposed to the chemical fumes, then there is possibility of rusting of heating element which causes failure of the heating element. Then mechanical consideration failure measure the heating element alloy contain iron which is brittle due to frequent heating and cooling of heating element. It may break, fail due to small mechanical injury also. So the causes of the failure of the heating element will be due to the corrosion, due to the oxidization, then mechanical consideration failure where the heating element alloy with the contain iron and it is also brittle. So the frequent heating and cooling of heating element may also break due to the mechanical injury or the force upon the heating element. Then corrosion happens because it is exposed to the chemical reaction, chemical fumes or the nature available gases, so it get corrode, so it may get chances of failure of the heating element. Then due to oxidization, that materials get oxidized which may cause the failure of the heating element. And the formation of the hotspot is there. Then unequal spacing, if the spacing between the heating element is non-uniform, then the temperature will be maximum, where space is maximum, minimum, and therefore hotspot may be formed. So the supporting structure also, if supporting structure is a bad conductor of the heat, then it will not transfer any heat, hence temperature of the heating element will be higher near and supports resulting in the formation of the hotspot. So this is the all we have discussed, that the temperature control element of the heating element and the causes of the failure of the heating element. So here we also discussed the comparison of the variation of the number of heating element according to the variation in the circuit configuration, according to the change in the applied voltage. So this all we have studied in this video. So from next lecture we will see the types of the heating, electric heating. Thank you.